Okay, in this lecture video, we're going to talk about compounds that have covalent bonds. So in our other video, we talked about compounds with ionic bonds that are made from a metal and a nonmetal, and you have positively and negatively charged ions. But in compounds with covalent bonds, we have neutral atoms, so atoms with no charge that are connected together now through bonding. And that connection that they make, that covalent bond, happens because they are sharing electrons. So rather than having one atom lose electrons and give them to another to form positively and negatively charged ions, now we're sharing those electrons between the two atoms. And each bond that we have, each covalent bond, has two electrons that are being shared. And remember, these electrons that are being shared are valence electrons. So in this case, we have to remember that there are no ions present. And these compounds with covalent bonds are composed entirely of non-metal atoms. So that's one really good way to distinguish between compounds with covalent bonds and ionic bonds. If you see a metal, you know it's ionic. So let's look at some examples of compounds with covalent bonds. Some really common ones would be water or sugar, which have these chemical formulas. So in water, what we see is a compound that has two neutral hydrogen atoms and one neutral oxygen atom, whereas the subscripts in sugar, which is C6H12O6, we see that we have 6 neutral carbon atoms, 12 neutral hydrogen atoms, and 6 neutral oxygen atoms. And again, these atoms are all in covalent bonds where two atoms are sharing 2 electrons. Now these are examples of molecules because they are composed, or I should say compound molecules, because they are composed of elements that are different. So these molecules are compounds because the atoms that are contained in them are all different. We have carbons, we have hydrogens, we have oxygens. We can also have covalent bonds with certain elements. And we call those elements the diatomic elements. So these are elements whose atoms never exist by themselves. And there are a total of 7. And you should know these for later. And they always exist as pairs. And those 7 elements are hydrogen, nitrogen, oxygen, fluorine, iodine, chlorine, and bromine. Let's count 1, 2, 3, 4, 5, 6, 7. That's everybody. So when we look at these, it's kind of funny. I wrote them in the order that I remember them because the mnemonic when I was in college was have no fear of ice cold beer. That was one way to remember who the 7 diatomics were. But what this means is that when you have plain old hydrogen, so hydrogen atoms, they never exist by themselves. They always exist as a pair. So when I say hydrogen or oxygen or fluorine, and I'm just talking about the element from the periodic table, you should know that if you were to write the formula representing, the symbol representing that, you should write it as a pair. So that rule, though, only exists, or only matters, they're only in pairs when they are alone as an element. So when these elements are part of a compound, so they're forming bonds with other types of elements, then this diatomic rule doesn't come into play. So one good example, then let's go back and look at water. It has a chemical formula of H2O. So this tells us that there are two neutral hydrogen atoms in this compound, but they are not H2, like the plain old element by itself. So if I were to draw a picture that represents what this compound looks like, or at least gives us an idea of what atoms are connected to one another, I would draw a picture that looks like this, where each one of these lines represents a covalent bond with two electrons being shared. So that means, for example, in this bond right here, there are two electrons being shared between this oxygen atom and this hydrogen atom. That's different than when we look at H2, so plain old, we call it elemental hydrogen. In this case, we have two hydrogen atoms that have a covalent bond, where now in this covalent bond, represented by that line again, you have two electrons being shared between the hydrogen atoms. Over here, these hydrogen atoms aren't sharing electrons with one another. So the diatomic rule only matters when you have bonding of those diatomic elements with each other. The diatomic rule does not matter or does not come into play when those elements are bonded with different kinds of elements. Let's look at one more example of that, and that example is calcium chloride. So in this case, right away you should say, wait a second, calcium is a metal, so that means, therefore, calcium chloride has ionic bonding. So this is not even a covalent compound. It's got a metal and a nonmetal, so we know that chlorine atoms are nonmetals. So this is ionic bonding. But I just wanted to point out again that when you see Cl2, this is not Cl2 like gaseous chlorine. It's not chlorine atoms. We know that instead, up in this case, what we have is two Cl minuses. So we have two chloride anions, each with a -1 charge, and that's what's represented up in this formula here. So it's not Cl2, it's two individual chloride anions. So just keeping the difference then here, covalent bonds are electrons being shared, and we've looked at some examples of elements that also have covalent bonds.